Conference participants, allow me to present the results of the work of a team of scientists from among the teachers of mathematics of higher education institutions of Ukraine. We have created an online platform, Higher School Mathematics Teacher. One of the areas of research is presented in the report on the topic. A competency-based approach to the systematization of mathematical problems in a specialized school. According to the methodological recommendations on developing the components of the state standard for basic and complete general secondary education based on the competency-based approach. The objective to form, develop and improve the complex of the students' competencies during the education arises for the system of secondary education. For subject teachers, the transfer to the competency-based approach means improving the system of problems to increase students' motivation according to the requirements of learning programs for students of general secondary schools. Mathematics is not an exception, that following the competency-based approach also implies the research of new methodological approaches and systematization of problems that will encourage the increase of students' motivation to learn mathematics. That's why learning mathematics should contribute to forming students' key competencies, among which there are mathematics competency and main competencies of natural sciences and technologies. One of such approaches is the demonstration of a constant connection between mathematics and other natural sciences to the students. In order to ensure it, the learning programs include the determination of cross-cutting lines of the key competencies, environmental security and traditional development, civil responsibility, health and security, entrepreneurship and financial literacy, that are focused on forming an ability to use knowledge and skills in real-life situations among students. Thus, while learning mathematics, a need to select and systematize the problems that allow demonstrating the use of mathematics in other subjects to the students, which will increase their motivation to learn mathematics, becomes quite urgent. Aimed at increasing students' motivation to learn mathematics, we chose an approach the implementation of which requires 1. Arrangement of learning programs in natural subjects in order to enable giving learning material where the use of mathematical concepts is described in parallel. 2. The realization of perspective cross-curricular connections of mathematics with other learning subjects on condition that it is impossible to provide the material in parallel. The mentioned approach will encourage students' understanding of how to use the acquired knowledge in mathematics in other subjects, ensuring both the formation of mathematics modeling skill and increase of students' motivation to learn. While choosing an approach, it was also considered that the motivation is internal if it corresponds to the aim of the student's activity. The conditions of learning activity, under which learning the content of the subject will be both the motivation and aim, are ensured. It is taken into account that internal motivations are connected with the student's cognitive need, their satisfaction that is obtained during the learning period, and as a result, the dominance of internal motivation is characterized by the display of students' involvement in the learning activity. Considering that one of the main content areas of the course, mathematics, in high school is the functional area, the article is aimed at the systematization of competency-based problems following the topic of the 10th grade, functions, their features and graphics. Also, The increase in students' motivation to learn mathematics through the demonstration of the tight connection between mathematics and other learning subjects is proven. While choosing the problems that will be included in the system, it was considered that the key message of the topic, functions, their features and graphics, should be the modeling of real processes using functions. Since working with diagrams, pictures, graphics is one of the spread types of a person's practical activity. The main objectives of learning a topic include the development of students' graphic culture. First of all, it is about reading graphics, in other words, setting the features of some function using its graphics. So, while choosing the system of problems for the 10th grade aimed at revealing cross-curricular connections on the example of the topic, functions, their features add graphics with other subjects, the following methods were used: primary research and data gathering, analysis of textbooks on different subjects of the 10th grade, analysis of mathematics textbooks of the 10th grade, systematization and structural analysis, selected problems on different subjects. The priority was given to competency-based problems. Data processing, the essence of mathematical modeling to show the use of functions in problems for different learning subjects of the school course was used. Based on such research methods, the problems for learning subjects of the 10th grade were systematized: physics, economics, chemistry, biology, information technologies, art, environment, geography, civil education, law, homeland defense, history of Ukraine that require the use of students' knowledge on the topic functions, their features and graphics. Let's look at the examples of the problems concerning the developed system. Environmental problem in which you need to correctly read the graphics of structure change in consuming fuel and energy resources and draw conclusions. The problem in physics is to write the equation of the function according to the given graph. Problem of geography requires the ability to correctly analyze the graphs of functions. Problem of the history of Ukraine uses another type of graph, namely histograms. Problem of biology, the function must be set tabularly, and on the basis of this table to build its graph. Besides, the problems from mathematics textbooks of the 10th grade on the topic functions, their features, and graphics were systematized, and they show cross-curricular connections between mathematics and other learning subjects and enable us to show the advantages of mathematical modeling in the research of real processes. We conducted an experiment in order to determine the efficiency of implementing a system of problems that show the use of functions in different tasks of natural subjects. The main objectives of the experiment were analysis of school subjects that are learned in the 10th grade, research of the learning process in algebra and basics of analysis in the 10th grade, development and implementation of the system of competency-based problems on the topic functions, their features and graphics that show the connection with other subjects, carrying out the analysis of the experiment results. The research basis included secondary schools where master students of the Specialization 014 Secondary Education, Mathematics, had their pedagogical practice. Master students who took part in the experiment attended training sessions to get acquainted with its aim and objectives and participated in the development of the system of problems and methods of conducting classes using this system. The teachers were told about the experiment and helped students to carry it out. The experiment was held during 3 weeks. The time spent on the topics, functions, their features and graphics. The control group teaching algebra is provided using the traditional methodology. The experimental group teaching algebra was provided using the methodology of demonstrating cross-curricular connections of mathematics through a system of problems on the topic, functions. In order to determine the internal student's motivation level, the following rating is used: 0 to 5 points, low level of internal motivation, 6 to 14 points, the average level of internal motivation, 15 to 20 points, high level of internal motivation. In order to implement the proposed system of problems in teaching mathematics, it is recommended to classify the implementation of interdisciplinary relationships over time. As a result of this classification, the authors of the article propose to establish 3 types of connections: parallel learning, perspective connections. Application of the method of mathematical modeling. Regarding the organization of interdisciplinary links in order to motivate them to learn mathematics, it is recommended to give students the opportunity to solve the selected system of problems in order to increase their understanding of the topic and develop their ability to model different situations, which in turn will increase their motivation to study disciplines. The authors of the research choose an applied problem as the main semantic item of the course. At the same time, we take a problem that is given outside mathematics as an applied problem and it is solved by mathematical methods and ways. Applied problems can conditionally be divided into such ones where the mathematical problem is included in the problem condition, formalized, and those the solution of which does not imply building a mathematical model, non-formalized. The solution to the first ones is much easier than the solution to formalized problems and consequently consists of the following stages. 1. Analysis of the problem formation. 2. Search for the solution plan. 3. Plan fulfillment, checking, and research of the received solution. 4. Discussion, analysis, of the found method to solve problems aimed at finding out its rationality, ways to solve the problems using some other method or way. While solving non-formalized problems, the above-mentioned stages are supplemented due to the need to build mathematical models. That's why we refer to the stages of solving non-formalized applied problems the following ones. 1. Problem setting. 2. Translation of the problem conditions into the mathematics language. 3. Creation of the problem mathematical model. 4. Search for the plan to solve the problem inside the model. 5. Plan fulfillment, checking, and research of the received solution inside the model. 6. Interpretation of the received results. 7. Discussion, analysis, of the found method to solve problems aimed at finding out its rationality. Ways to solve the problems using some other method or way. Extensive and multifaceted interdisciplinary connections of mathematics with other school subjects can become a guide for students to study other disciplines. Also, through the demonstration of interdisciplinary connections of mathematics with other disciplines, the formation of mathematical competence in high school students is a key one. The positive results of the introduction of the system of interdisciplinary problems in the process of teaching mathematics on the example of studying the topic functions. Their properties and graphs shows the increase in the level of motivation of students, recorded during the experiment. We see the prospects for the development of the topic in research focused on the development of competency-based teaching methods of such school algebra courses as derivative functions, integral and its application, as well as on preparing students majoring in 014 secondary education mathematics to implement interdisciplinary links in learning mathematics. Thank you.